Hey everyone, and welcome to This Explainer. Today, we're unraveling a bit of a mathematical mystery. We're looking at the exact mechanics of solving linear equations. We're going to break this all down using a really structured, visual approach that strips away the confusion and just makes total logical sense. Okay, let's dive into this. Our puzzle today is this. 3 times the quantity x minus 5 equals 2x plus 15. So what is x? Now, I want you to look at this equation not just as a random string of numbers on a page, but as a perfectly balanced scale. On the left side, we have a very specific, concrete weight. And on the right side, we have an entirely equivalent weight. Our whole objective today is to strategically manipulate these weights, carefully maintaining that perfect equilibrium, all so we can reveal the hidden value of our variable x. So here's our roadmap for today. We'll start with the equation mystery, then move on to unpacking the brackets, grouping the variables, isolating the unknown, and finally, verifying the solution. Section 1. The equation mystery, mapping the journey. All right, our master plan has 4 distinct phases. Think of it almost like a rescue mission for the variable x. First, we expand the brackets. Next, we group the variables together so all the x's are on one side. Then, we isolate the variable completely. And finally, we verify our answer to make absolutely sure we got it right. Section 2, unpacking the brackets, entering the equation. To actually unlock those brackets, we have to use something called the distributive property. And hey, fun fact here, the word algebra actually comes from the Arabic term al-jar, which literally translates to the reunion of broken parts. And that's exactly what we're doing here. As it's defined, we're multiplying the number immediately outside the brackets by every single term inside. In our original equation, the number outside is 3, and the terms inside are x and a negative 5. Let's walk through the actual multiplication process right now. First, we take the 3 and multiply it by the first term, x, which simply gives us 3x. Then we take that exact same 3 and multiply it by the second term, negative 5, which gives us negative 15. We are essentially distributing the mathematical weight of that 3 across everything inside those parentheses. Let's move to and see how this builds. By applying that distributive property, we can rewrite our initial equation into these much simpler terms. 3x minus 15 equals 2x plus 15. See that? The brackets are totally gone, but because we strictly followed the rules of math, our imaginary scale is still perfectly, flawlessly balanced. Section 3. Grouping the variables, gathering the suspects. Right now, we have x terms sitting on both sides of the equal sign. To fix this, our goal is to get all those x terms over onto the left side. Look at the right side of the equation. We've got a 2x over there. So how do we cleanly remove it? Well, by performing the opposite operation. We need to subtract 2x. But remember our perfectly balanced scale? If we subtract 2x from the right side, we absolutely must subtract 2x from the left side as well to maintain that exact equilibrium. Here's what that looks like. On the left, we take our original 3x and subtract 2x. We just leave the minus 15 right where it is for now. On the right side, we take our existing 2x, subtract 2x, and leave the plus 15 alone. We are carefully, actively adjusting the mathematical weights on both sides of our scale at the exact same time. And just look at the result here. When we subtract 2x from 3x, we are left with simply a single x. On the right, 2x minus 2x is mathematically 0, so that vanishes entirely. Our new, much cleaner equation is just x minus 15 equals 15. The 2x is completely gone from the right side. We are incredibly close to finally solving this mystery. Section 4. Isolating the unknown, the reveal. Our current equation is x minus 15 equals 15. To isolate x completely, we need to move that negative 15 over to the right side. We do this by performing what's called an inverse operation. Think about it. What is the exact mathematical opposite of subtracting 15? It's adding 15. But again, the golden rule of algebra totally applies here. Whatever we do to one side, we must identically do to the other. So we add 15 to both sides of the equation. And this brilliantly illustrates the final balancing act of the equation. On the left side, we have x minus 15 plus 15. That minus 15 and plus 15 perfectly cancel each other out to 0. Leaving x completely, entirely alone, just what we wanted. On the right side, we perform the addition, 15 plus 15. The mechanics here are just so elegant, right? It logically ensures our scale remains perfectly level throughout this whole operation. Which brings us to the climactic reveal. 15 plus 15 is 30. Therefore, x equals 30. We have successfully isolated the variable and found the hidden value. But wait, are we truly finished? Section 5, verifying the solution, the alibi check. A true math detective always checks their work. We do this check by taking our newly discovered answer for x, which is 30, and substituting it right back into the original scene of the crime. Remember that original equation from the very beginning? It was 3 times the quantity x minus 5 equals 2x plus 15. So everywhere we see an x in that equation, we are going to literally plug in the number 30. Let's see if the scale actually stays perfectly balanced. Now, what's really interesting about this slide is the beautiful symmetry of this proof. Let's look at the left-hand side independently. We substitute 30 in for x, giving us 3 times the quantity 30 minus 5. Well, 30 minus 5 is 25, and 3 times 25 gives us 75. Okay, now let's calculate the right-hand side. We plug in our 30, giving us 2 times 30, which is 60. We then add that remaining 15, and 60 plus 15 is exactly 75. So, the crucial point is that the left-hand side perfectly equals the right-hand side. 75 equals 75. Because that balance has been mathematically proven, we can definitively confirm our solution is absolutely correct. X truly does equal 30. I want to end with this thought to leave you pondering. Are equations just a series of tedious chores to memorize? Or are they perfectly balanced, undeniable logical loops that elegantly reveal the hidden order of numbers? Think about the precise, step-by-step logic we just used to dismantle that problem. It's not just math, it's structured problem solving. Keep exploring that logic, keep rigorously verifying your work, and I'll catch you in the next explainer.